Most modern test equipment that measures jitter falls into one of two broad categories: time domain and frequency domain. Time domain equipment typically comes in the form of a high-frequency digitizing oscilloscope with high single-shot sampling bandwidth. Frequency domain equipment usually comes in the form of a spectrum analyzer with phase noise measuring capability, or a phase noise analyzer. Each of these two categories of equipment has its advantages and disadvantages. Even though jitter is usually a time domain term and frequency noise is typically a frequency domain term, it is common for these terms to be used loosely and sometimes interchangeably. Theoretically, with perfect measuring equipment, if one were to integrate the phase noise from the carrier out to an infinite offset, the phase noise and the jitter would have the same numeric value. However, given real-world and practical test equipment, this is simply not possible, and there will always be a discrepancy between the two measurements. In spite of this, it is important to remember that the time and frequency domain approaches are both measuring the same phenomenon, even though the exact results would depend on the details of the measurement process and the equipment used. Let's next take a closer look at the key differences between these two approaches to measuring jitter. Time domain equipment has the virtue of being able to directly measure peak-to-peak, cycle-to-cycle, period, and tie jitter. This measurement approach permits the measurement of jitter of a very low frequency clock or carrier. By post-processing the data with techniques such as FFTs and digital filters, it is possible to integrate the phase noise value over a specific band of frequencies to generate RMS phase jitter values. Only time domain equipment can measure all of the jitter frequency components. Another key point is that time domain equipment is much better at measuring data-dependent jitter, which makes it very useful for high-speed serial links that use serializer-deserializer or SerDes technology. Frequency domain equipment cannot directly measure peak-to-peak, cycle-to-cycle, or period jitter because its native capability is to measure the RMS power of signals in a given frequency band. Frequency domain equipment is also awkward for measuring data-dependent jitter. However, the best frequency domain instruments have a lower noise floor than the best time domain instruments. This makes frequency domain instruments the first choice for ultra-low noise clock signal measurements.